Bayer's Law. We are going to be using Bayer's Law to determine an unknown concentration. So the chemical that we're working with is this green stuff here. So this is a copper solution. We have a copper sulfate solution. We don't know, it's not shown on the bottle what the concentration of this is. So we're going to determine that. In order to determine the concentration, we're using Bayer's Law, and in order to use Bayer's Law, we're going to need to take some absorbances. So we have the vernier and we have a colorimeter. You'll notice that the colorimeter is not as, diverse as a spectrophotometer. We only have 4 wavelengths available to us, and you'll notice that the wavelength chosen is 635. So we're going with that. That's where we're going to get some of our highest absorbances for this particular chemical. Now, in order to do this, one of the first things that we have to do is get what's known as a cuvette. We have to have something to put our sample into. And so when we look at the cuvette here, so if we just kind of come off to the side, just so we can kind of see if we can get it to focus. You'll notice that when we look through the cuvette this way, it's crystal clear. And when we look through the cuvette this way, it's kind of foggy. So the idea is that the light's going to pass through the super clear sides. And in order to make sure that the light's passing through it really well, you don't want to make sure there's any like fingerprints or anything on there. So the idea is that you always want to handle it from the sides that are fluted like this, so that they kind of give a fogginess. And we always keep a nice clear front and back. So I'm just going to wipe this off and get it nice and clear. And what we want to do, the first thing we want to do is we want to calibrate our machine. Remember that while the absorbance of something like this is not going to be very large because it's clear, there still will be probably a tiny little bit going on. So right now we're actually getting an absorbance happening here. And when you open up the machine, you'll see that this is where the cuvette fits, and there's nothing in there, but we're still getting some type of absorbance. And so just like when we weigh something on the digital scale, we want to tare it. That's kind of what we want to do here. So what we're going to do is we're going to take this and we're going to fill it with just plain old distilled water, since distilled water is what we used to make all of our solutions. So what we know is when we look at this, we see sort of a little the triangle here. This is the path that the light is taking. And so we're going to make sure that the clear sides always go in line with that. So we'll go ahead and set it in. We're going to close the lid, and then what we're going to do is we're going to calibrate it to our sample. So it's going to basically remove all the absorbances that we're reading right now. So we'll go ahead and hit calibrate. Once we do this, we should only ever do it once. Didn't really want to, what's going on here? There we go, we're flashing. So hopefully we'll zero out here. There we go. So we see that our absorbance has gone to 0. So this way, it's not taking into account any of the absorbances inside the machine from the things that the light's passing through, the water, etc. So now what we want to do is get our curve. Remember that we need a curve so that we can find y equals mx plus b. And so we have to have some known concentrations. So it's going to be up to you guys to first come up with how we would actually make this original solution. So when you look at the directions, it says that you're supposed to have 40 milliliters of a 0.4 molar solution. So I actually already made 40 milliliters of a 0.4 molar solution. So there's not 40 here because I've already made some of the following solutions. And you'll notice that there's 5 different test tubes that we're supposed to mix up. And we start with 2 milliliters of the 0.4, and then we go to 4, and then we go to 6. So basically it's getting more and more and more concentrated. So if we look over here, you can see exactly that happening. So when we're looking at our substance here, we can see that the color is getting darker. So this is the palest moving over here to the darkest. So this is full strength, 10 milliliters of the 0.4. This is only 2 milliliters of the 0.4, and then I filled the rest with water. So it's going to be the most dilute. And it's going to be up to you guys to figure out what the concentration of each of these things would be. So that is your first task. Now what we want to do is get a sample of each one of these things, and we want to read what the absorbance would be for each test tube, and we're going to plot that. So let's go ahead and get that cuvette out. And so now what we're going to do is just fill the cuvette with each one of our solutions. And find their absorbances. So here's our first one. This is test tube number 1. Okay. Gonna get a sample of the next one now. And what I do to make sure that the sample isn't diluted at all is you take just a little bit and put it in there, shake it up, and then dump that sample out. So that way it's removed any of the previous one that might have messed up the sample at all. So. So we are on sample 3 now. This one's having a little trouble stabilizing here. And on to our last one. So I get a little bit, rinses out my pipette, and it rinses out the cuvette so that we know we have just this concentration in there. And now for the last one. Now we just need to get our unknown. I gotta be honest, that trial number 4 doesn't look so good. A little worried about that one. There's not much of a difference between these two trials. I'm wondering if I screwed something up. Let's do this. We're gonna do trial number 4 one more time. I'm gonna mix that up again. So trial number 4, we need 8 milliliters. Just seems like those are awful close together, so hopefully. So we've got the 8 milliliters. And let's just put 2 water in. Just flush it around. Maybe it didn't mix up too. That's always a possibility. Okay, so this is our trial number 4, test tube number 4 being done one more time just to see if that number made sense. Yeah, this looks better. You know what could have happened was this one had so much that went in. It was 8 milliliters and then 2 water on top. And I put the 8 in first, and it's more dense, so it might not have mixed. I don't remember if I swirled it around. I don't think I did. I like this number better. So we're going to go ahead and change trial number 4 to this one. It's either that or I did the same test tube twice, which is a possibility, but it's definitely was less than that, than number 5. So 7, 6, 9. Yeah, okay, so now our numbers look like they have a little bit better increment of change there, because we're expecting this to be a straight line, according to Behr's law. So we're going to go ahead and try our unknown now. So let's get the unknown rocking here. Lid on here. All right. So at this point, we have unknowns, the absorbances for our knowns. So we should be able to take those values and graph them. Now, there's a Google Doc or a Google Sheets that has been attached to the classroom assignment. And you basically want to put your information into there. We should be graphing concentration versus absorbance. And we can insert a line of best fit. And when we insert a line of best fit, we can ask it to show the y equals mx plus b equation. So you should be able to use that y equals mx plus b equation to solve for the unknown concentration when it has that for your absorbance. So if you guys have questions, let me know. Hopefully this is quick and easy for you.